Yeah, so hi everyone. My name is Karaoke Evans. I want to take you through a session in IoT whereby we'll just do a simple demonstration of a blink of an LED and we do one for traffic light system. Yeah, so in briefly, let me just mention what is IoT. IoT is just a network of interconnected devices. In full, it's Internet of Things. So anything that is connected to the internet that qualifies to be one of the network of the IoT devices, nodes connected together. So in IoT, basically what mostly is used is a microcontroller. It's like think of it of like a tiny computer. If we take an example, we can pick something like a washing machine. A washing machine has got some maybe buttons, knobs, and everything. So the small computer in it is programmed to work according to the instruction given to it. If maybe one presses a certain button, maybe it should do this and this and this. Yeah, so I'll just start by, let me open my editor. So we are going to use Arduino IDE, and for some purpose, I'll have to run it as an administrator. IDE, so you proceed to File. I want to create a new sketch, so new sketch there, and a pop-up will come whereby we will do a new program. Yeah, so this is our programming field. We want to do the code for blinking an LED, and it will be very simple. So first thing what you need to do, if you're working with a different board, so you need to add your board manager. So you proceed to File, then Preferences, and here you see where you'll see something written additional board manager URLs. So you'll first have to proceed to Google, and then you can search maybe the board manager URL for ESP8266 or maybe for ESP32. You copy that link, then you come and paste it here. And if you have maybe multiple boards, for example, you are working with an ESP8266, maybe an ESP32, an Arduino Uno, etc., you will have to separate the URLs with a comma. So then you press OK. The next thing you need to do, it's like configurations. So you will proceed to where you see tools, and after tools you move to where you find the word board. So you select the board that you want to work with. For example, I have ESP32 and ESP8266, and since I'm working with ESP8266, I'll proceed to select the specific version of the ESP that I'm working with. Some usually work with multiple, like mine can do with this, do it generic, this one multiple. So I'll select that one, and then you need to change or check the common port. For instance, this common 8 here, sometimes you'll find it's connected to common 9, but you don't have common 9 at the serial ports available here. So I'll proceed with common number 8. So what we'll have to do here, let me comment what the program is. The code is we want to create a code for lighting LEDs. So LED blink. Let me just say LED blink code. Yeah, the first thing you need to do is you declare whatever you have, or you define the pins that you're working with. So let's do the definition of pins. So here we define them this way: const int, then we are just having one LED, so we can name it the way we want. So let's name it LED, then the pin, we give it the pin number that we want to work with. For example, I'll work with 13, then you cross that. Now you're done with the definition of that pin. So the next thing you will do, you go to the setup, because now you're done with that one. Okay, here for setup, this is the runs only once. For example, if you want your devices to connect to the internet, maybe to the Wi-Fi, it will just run the void setup once, connect to the Wi-Fi, and then start running your loop function. So in the void setup, we want to proceed and give the pin mode of our LED. Since an LED is an output device, we'll give it a pin mode of an output. If it was maybe a sensor, maybe you want to capture the motion, if there is motion, at that moment we would have done it as an output, as an input, because a sensor usually sends data to the microcontroller. So we pick the pin. Here we use the camel case, if I'm not wrong. Pin mode, the pin mode that we want to give, so it's the LED pin that we want to give a mode of an output. By the way, this is a C++ that we are programming with. Don't be worried if it's your first time. Yeah, so that is the pin mode. Now we are done with that. We can proceed. Okay, this loop, this is the main function of our program. So here is where we usually indicate what do we want with our program. If we want some delays, some printing of the maybe what is happening, etc. So I will proceed to writing what do we want. So in C, let me write something here. digitalWrite LED underscore pin high. So for this line here, what it does, sending a digitalWrite, we are telling the LED to do something. So we are sending a signal by writing. But if we want to get a signal, we will use read, because we want to read from the connected device. So far we have sent a signal. High is like in binary. High is 1, meaning the LED should be on, and a 0 is low, meaning the LED should get off. So now here what we want to introduce, it's a delay. After the bulb goes on, do we want it to be on forever, or the LED? No, we want to have a delay. So we introduce a delay of like maybe 5 seconds. Delay of, let's say here we have to, these are microseconds, so of 5 seconds, and then you close. With that, we have given the LED a command to put it high, like to light it up. Now we want to give a command of shutting it down. So we just copy that and then we give it a low here. And same way we introduce a delay. Delay of let's say 2 seconds. Yeah, so that is it. Here the LED will go on, then stay on for 5 seconds, then the LED will go off for 2 seconds, and it will keep running forever and ever. Yeah, so that is how simple it is. Now when you want to upload your code to the microcontroller, you usually come here. If you hover there, you will see it's written upload. Here it's verify. So we are going to upload the code. That is sending the program to our microcontroller, and from there you will not need to have to connect it to the machine. So send. If there is no error, it should upload that code, but if you have made any error, it should be displayed here. As you can see, here this line there is an error, we forgot that one, so we resend it and we'll see the output. It's compiling our sketch. Wow, and it's doing the connection. Everything is running smoothly. Now you see our code is uploading. We have finished compiling. It's uploading to our board, and boom, 100%.
So for the first setup, whereby we want to run just a program to light one LED, this is the setup from this microcontroller here. We want to light this LED here for 5 seconds, then a delay, etc. So I have connected it to this pin here. That is the one that is connected to this LED to the positive terminal. And then I have sourced its power. As you can see, it's not connected to another device or an like maybe my PC. I have sourced its power from this microcontroller here. Yeah, so this device has got a VIN port. That is the one that is capable of taking power from another source, maybe a battery or etc. You can also power it from an adapter from this port here. So I have sourced power from this setup here. We'll get to it. Yeah, and then let's connect the setup. As you see, our bulb has gone on for 5 seconds, our LED, then off for 1.5 seconds, on again, off. So that's it for that one, for the one LED.
Our first sketch ran smoothly, so let's proceed to the next one. So this one we were doing the one for blinking an LED, and now I want to proceed to building one where we will simulate traffic lights. We will have color red, green, and yellow, 3 different LEDs, so that we can see how to go about that one. So we will follow the same thing that we have worked here. Yeah, so but let me clean it. So let me comment this traffic lights. Let me call it a system. Yeah, and what I said, we start with defining the digital pins that we want to use. So we define digital pins, and for this one we are going to use 3 because we have 3 colors. The first one, I said we define them using constant int. Then let's give the first one red LED. We want to define a pin for it, and let's just pick number 14, and since the same line will be repeated for the other colors, we just paste it there, then we change the name, the definition of the pin. Let's proceed with this one, maybe being green, and the last one yellow. I hope that is the order they usually follow. For the yellow one, let me pick pin number 4, and for the other one, for the green one, let me just pick maybe pin number 12. So you have to select the pins that, if these ones you want them to be outputs, you have to select the pin that is an output. So after that, I want to introduce something that I had not mentioned before. I can define the delay time here. So let me, this is delay. Yeah, I can define it here. So I can just use const int, then I'll give it a delay, and this is the time, and the delay time, this is in milliseconds. I want it to be, let's say, 3 milliseconds. So I've given it there. So then I can proceed to the, I'll show you the reason as to why I've introduced this new one here. So I'll proceed to the setup, and the first thing is initializing all the pins as outputs. And by that we will have to write the pin mode that we want to give our pins. If let's use the camel case, pin mode for the first one is the red LED. We want it to be an output, and the same thing will happen to the others. So I had forgot this one here, so we will have to copy and paste for the others. The good thing with programming, you just have to change some different things here. Green, the same is an output, and then the other one is for yellow, and it's an output too. So by initializing that one, you have already told your microcontroller that I want that pin mode to work for output only, because sometimes there are some pins, the GPIO pins, general purpose input and output pin, they usually have you can use it as an input pin and as an output pin, but there are some reserved pins for specifically output or input. So you have to make sure when you're selecting these ports here that you are sure the pin is an input or an output pin, so that you don't mess up somewhere in your code. So after that, I'll do something that is optional. Because we have 3 LEDs here, and we want, whenever we connect our device to power, we want every LED to be off. We'll write them as low when we are connecting, we connect it to power initially. That is for giving it a smooth start, or a clean start to say. So let me just comment it as low for LEDs. Then we'll do the digitalWrite, and what is it that we want to write is the red LED. We want it to be low meaning we want it to be off, and since we want that to every LED, we'll have to paste it and then change this one to yellow, and this one to green. Now, having done that, we are done with our setup. Because we are not connecting to the internet right now, we don't have anything else to run in our setup. So we just proceed to the main function, where that is our loop. And in our loop, we will have to give each and every pin what we want it to do. So since it's a traffic light system, we'll start with the red one, give it some delay, proceed to the green one, give it some delay, etc. So I'll just copy this one here, the same statement. The good thing with this, you just proceed to this point here where our loop is, you paste it. So we are writing the red LED. Now we will change it to high because we want it to be on. Turning red LED on, and the others remain off. So this one, the same code we have copied here, we will do the same thing to the others. But when we turn this on, if we don't introduce a delay, it means that one will remain being on. So we introduce a delay here. So the delay, and the delay that we want here, it's of maybe, okay, sorry for that. We want a delay of 2 seconds. So delay of 2 seconds. And after that, remember we had defined we want a delay of 3 seconds. This is the delay time that we had defined here. Now I want to introduce the second part. So this is the red. This is red LED. And now we proceed to the green. Is it the green LED? Now for the green, we'll just change here the state to be high, and with that we'll have our green LED on, and then we will change our delay. Now we'll shift to delay, and we'll use the delay that we have here, delay time that we had defined here. We call it now here. That one will introduce a different delay with this one that is up here. You can decide to give it delay that is of 2 seconds as we had done it here, but now these are a different strategy, so you will pick the one that suits you best. And then we copy the same thing, and then we paste it here. For we have the last one for the yellow. Yellow LED, we paste it there, and change the other values. This we want it to go low now, and yellow one we want it to be high. So after that, you close that one there, and these one too, you close it there, and that is done. But now I want it to have some change. This is a delay of 2, this is a delay of 3 seconds. Now I want to change this one to a delay of 4 seconds. Let's just do that. Then all that being said, we have something that is called free RTOS. Let me just write it here. Free RTOS. That is a free real-time operating system. This is another concept that was introduced. Instead of having to run the setup, then start a loop. For instance, if you have multiple devices that you're connecting to your microcontroller, you have a lot of sensors, you have to capture data from an API, etc., etc. This one can be can cause maybe some damage or some failures. For instance, if you have in your setup, this one is the one that runs first before the loop. If in your setup you had given it maybe to run a connection of internet, then after that it start the loop, it means if your microcontroller fails to fetch that internet or that Wi-Fi, it means it can't proceed to doing the other tasks. And maybe this is a device that is supposed to be used in a smart home, whereby you want to monitor motion, you want to monitor in case there is gas leakage, you want to monitor in case there is too much temperature exits in a certain room. Maybe you want to capture your cameras, the data from your cameras. It doesn't mean that if I come in your place with a signal jammer, you won't be able to detect that I've come there, because your devices will lose connection. So we have a way that you can escape that and break everything into tasks. For instance, you have task for capturing motion, task for capturing internet connectivity, task for... So in case one task fails, that doesn't mean the others won't proceed. So in case there is fire outbreak, the task for capturing signals from the fire sensor, it will send signal that there is fire, and you will be able to react, or according to the actions that you have put across, it will be able to be put off. So that is a concept that will be introduced in the next coming lectures, or do I call them session? Yeah, the next coming sessions. Yeah, thank you for your time. That was for today. Let me proceed to uploading. Let's run this code now and see what we will be given in our output. Okay, seems to have failed in the connection. If you see this part looking this way, it means the connection might not work. So let's just cancel this and restart our program. We have not saved this one. Let me just copy it, then we can close, don't save, have it copied. Then let me close everything, run the ID again, run it as an administrator. Then we proceed to our new sketch. We copy the code that we paste the code that we were working on. Then here we change the board. You see now it's in ESP82, but we want this one. Do it. Then we come here for ports. It's connected to port 7. I think that now should do. I believe that should work. It's compiling, and we have a bunch of errors here. trace back module write bin. So let's run the code. COM7 not found, so we change that port. Okay, COM number 8. Let's proceed with that one. Yeah, and now it's done the connection. Sometimes these things just decide to work the way they want, so you have to try and do what you have not tried. Yeah, so the setup is done and it's running.
So let's move to the next setup here. For this setup, this is where you are connecting 3 different LEDs. So this is a red one, this is a yellow one, and this is an RGB red, green, blue. But at the moment, I'm going to use the color green alone. So as you can see, I've connected it. This is a breadboard. Here we have a negative line and the positive. They run this way. So if you connect this one, this is the 5 volts. If you connect 5 volts to this line, everything connected to this line will pick 5 volts, but this one is powering the other microcontroller. And for that, when I connect it to power, as I had done the setup, we have connected it in a way that when I power it, only every LED should first be off, then it start the loop function. I'm going to power it on. So as you can see, okay, I have an issue with this one here. There is some loose connection. Yeah, and it's fixed. So red for 2 seconds, yellow for 3 seconds, then green for 4 seconds. That is how the traffic lights usually work. Yeah, these boards usually run on low power. As you can see, one device can power another one, and I have connected it using the USB, which at most the output for an USB from a laptop is 5 volts. Yeah, so that is the setup. Thank you.
I'll